Okay, Zaidee's mirror trick again. This is my second go at explaining this because I forgot something first time. So the idea, remember, is that the rule for reflection from a mirror is that if you have a light ray come in here like this, make it thinner, it'll reflect off at an equal angle, like that. And maybe let me label this like the incident angle theta I and the reflection angle theta R, just to be clear that they're different. They're sort of different angles geometrically, and the rule of reflection is that the incident angle is equal to the reflection angle. So if a light ray or photon comes in there, it'll come out here at the same angle that it went in relative to this dashed line, which is the perpendicular 90 degrees to the mirror. Okay, so we can get maybe some angles to the camera, one like that. Oh, it's going to miss the camera. But there's maybe one like this, comes in around the same point, and those will definitely hit the camera. So you will be able to see roughly this little piece of the box here. So to do that, you'd have to move that a little bit. You'd have to go over here, or you put your eyeball here, and then you'll be able to see. And an easy check to see that that is what is happening, that you're only able to see a little bit of the box. I mean, obviously you should be able to only see a little bit of the box, but if you don't, let me know. So let me know, because there'll be some magic going on. So if we make the paper wider, we can block those two rays out there. So I'll make those kind of dark, right? Well, there'll still be light coming scattered. There will still be light scattering off the box. You know, there's some light coming in here and here and everywhere. Okay, light from all over the place. The sun, the curtains, the ceiling lamp. Okay, but some of it, when that light comes in and hits the box, it scatters off in all directions. Okay, but you only need a few of them, like a few hundred, to be able to see something. And of course there's billions of them. So this one, you'll still be able to see a light ray from here to here, and that'll reflect off to here, and you'll still see one from here to here, and that'll go, and that'll go to there, and so on. And so all Dad has to do is move a little bit. Just has to go over here, and then he'll be able to see them. Okay, but that didn't answer the question of why it looks like there's magic. And the reason it looks like there's magic involved here is because the light coming from the box here preserves all the information about color, depth, perspective, and so forth. And so what it looks like to your brain is, it looks like if you go just backwards, keep making this ray here go backwards like that behind the mirror, and this one as well, it'll look like there's a pink box around about here. Okay, and of course the paper as well. You'll see a little bit of the paper, but you'll notice you'll only actually see the front of the paper, not the back of the paper. So it won't actually look like this. Okay, so anyway, I'm not drawing it exactly correctly. So that's called a virtual image. It looks to your brain like the pink, that this yellow light ray is coming as a pink one coming from behind the mirror, because that's where it looks like, that's where your brain makes it look like that, because of the perspective information, because of the color information and the shading and everything like that. But in fact, the light is only coming from this point on the mirror, and this point on the mirror, and this point on the mirror. those points in the middle. It's the only place the light's coming from. It all comes from just here. But it looks to your brain like it's coming from some place over here because of the perspective, because of the color depth and the shading and everything like that. And so the actual distance the light travels is only this distance here, d. But it looks like it's traveling this distance from here to here. It looks like it's traveling this long distance here. So that's how far away the image of the box looks to you. It looks like that far away, d dash. But it actually, the light is only a distance, little d from here to here away. A smaller distance because it's coming from the mirror. But your brain can't tell that it's just bouncing off the mirror, right? Your brain just makes it look as though it's coming from over here. So it looks like a 3D kind of situation. And that's the same as the movie theater, right? So at the movie theater, you've got a screen, and then you've got some light rays bouncing on the screen, making up some movie pictures and so on. And there's a camera projector over here in the back of the theater that's got a intense light bulb. It's pumping out white light. Well, actually red, green, blue light, I suppose, pumping out these different colors, and then on the screen they reflect back into your eye. You're sitting over here somewhere, and these light rays from the screen, go into your eye, and from various locations on the screen, and that looks it's going to look 2D, right? So it's going to look 3D because of the color, the depth, the perspective. Whereas in fact on the actual screen, it's only two-dimensional. So that from the movies and from TV that a 2D picture you can make it look 3D if you get the coloring and the shading and the perspective right. But the mirror does that automatically for you. It gets the color, the shading, and the perspective right. So to your eyes, to your brain, it looks like the box is behind the mirror, but actually you're just looking at photons that are bouncing off the mirror at these locations here. All right, hopefully that's a better explanation. Catch you next physics question. Bye for now.